I wanted to show the science of lifting large objects. I guess leverage, something I figured out the other day. So when you do team lift at like a store or something, when you're lifting large merchandise, you have two people lifting it, so it's half the weight for each person. So I was thinking, okay, if you lift just one side of it and the other side's on the ground, doesn't that mean you're only lifting 50% of it and the other side's supported by the ground? And then as you get it higher up, you're lifting even less weight because gravity is pulling on it less in that direction. So let's test that theory real quick. I'll first lift one side, then I'll try and lift it from the middle, and we'll see what happens. Okay, I'm lifting the one side, and I can lift it pretty easily. Now, try and lift it straight from the middle. Definitely twice as heavy. Can't even lift it. Definitely harder to lift. Okay, so that out of the way, I wanted to show you the next part of that theory. So let's say this is the fulcrum right here. That if you have the fulcrum all the way on one side, you're technically lifting 50%. If the fulcrum is in the middle, the very middle, you're lifting 0% of the weight because it's distributed evenly. So if the fulcrum's like right here, halfway between the middle and the edge, then you're going to be lifting 25% of the weight, and so on. You can go down to 10% or whatever. So you can lift any sized object, and you see this thing is massive. You can't move this normally, but it's on, the fulcrum is probably a little bit off center, so I'm probably lifting about 10% of the weight right now, but it works. I mean, you can probably, let's see, let's go to this side. With just like one hand, you can put it downward or upward, whatever. But you can either move it sideways or you can lift one side. Yeah, let's see here. Lift one side like, as long as it doesn't roll off. But you can lift one side up and put something underneath it. Lift the other side up, put something underneath it. You can go upwards, or you just go along the track. Which, if you think about it, if Stonehenge was just one long stone, you got lots of leverage if you're in the center of that stone, so it acts as its own lever. And if you didn't have a long object and it's just a really big square object, then just put a lever on the top of it and you can tie a rope around it or something and work the same way. So this is probably how they moved Stonehenge stones, those hundreds of miles or whatever it was. They didn't need to make a wheel out of the stone or anything, or a wood wheel around it. You just need to walk it along the ground like this. I don't know exactly how they did it, but it's a general theory. So I hope you learned something.